We are in chemical reaction, and I am actually taking this class as a supplementary class of the previous class. And what we are going to do in a chemical reaction, there are many compounds which are given in their commercial name. I mean to say, commercial name of the compound is if written, then you must know what are they. I mean to say, chemical name can be written easily. Just for example, if somewhere written magnesium chloride, you can write magnesium Mg, chloride means Cl, chlorine is combined, magnesium valency 2, chlorine valency 1, and 1 we don't have to transfer, magnesium 2 can be transferred this way. This way, if anything comes which we know the chemical name, then we can write easily. But there are so many compounds, they have commercial name, and we don't know, looking at their name, what element they have. That's why we have to remember all these, otherwise we will not be able to write chemical equation or chemical reaction, and we will not be able to balance the chemical reaction. That's why I'm talking about them. Look at this, looking at ammonia. If ammonia is told, then no one can understand that it has nitrogen and hydrogen. But we have to remember that ammonia's molecular formula is NH3. We don't have to transfer, we have to just remember this. And methane doesn't say that it has carbon and hydrogen, but you must know its molecular formula CH4. And somewhere if it comes ammonia when reacts with water, then what happens? Then if you don't know what is the molecular formula of ammonia, then how can you write the chemical equation? That's why we must know all this. Silica means silicon dioxide. If silicon dioxide is told, then we can write this. But if silica only told, then sometimes we may be confused. That's why we have to remember this. Quicklime doesn't say that it has calcium and oxygen. And in the same way, slacklime means calcium hydroxide. Calcium hydroxide is slacklime. And limestone is calcium carbonate. If limestone is heated at high temperature is told, you must know its molecular formula calcium carbonate, and then only you will be able to write this. Okay, marble is also calcium carbonate. The hard form of marble, calcium carbonate, is marble, and limestone is a little softer than marble. This is also calcium carbonate. There is another chalk also, calcium carbonate. Hydrochloric acid, looking at this, if you don't know, it is made up of hydrogen and chlorine. Instead of hydrochloric acid, if it is a hydrogen chloride, then we can understand hydrogen as chloride means chlorine is combined. We will write this way, hydrogen and chlorine combined with each other. This is a gas. And equal valency, no exchange, one valency of each. But hydrochloric acid, you must remember, this is in the form of liquid HCl. And then sulfuric acid, H2SO4. And nitric acid, HNO3. Have you noticed this? Each of the acid contains hydrogen. Carbonic acid, H2CO3. In the same way, acetic acid, CH3COOH. These are the acids. All the acid contains hydrogen, which when dissolved in water gives hydrogen ion. Caustic soda, this is sodium hydroxide, NaOH. And this baking soda and washing soda, they seems to be similar. Baking soda means sodium bicarbonate. Now the valency is already exchanged, and you have given just the formula. And water, if I am talking about water also, but water doesn't say that it has hydrogen and oxygen. That's why you have to remember that water, its molecular formula is H2O. H2O. And another, carbon dioxide. It seems to be so funny to remember carbon dioxide, but actually carbon dioxide, why I told you? Because carbon when combines with oxygen, then if we transfer the valency, I mean to say exchange the valency. If we exchange the valency, then what happens? Look at this. Carbon valency 4 is given to oxygen. Oxygen valency 2 is given to carbon. 2 atoms of carbon combines with 4 atoms of oxygen. It means 1 atom of carbon combines with 2 atoms of oxygen. That's why instead of writing this, we write CO2. That's why to be bother with all these explanation, I gave you directly carbon dioxide, CO2. Carbon monoxide. Now, why I gave you carbon monoxide also? Because carbon and when oxygen combines, then this is unstable compound, and if we exchange the valence, you will not get this carbon monoxide, we will get carbon dioxide. That's why it is better to remember this. I think many of these you remember already, you have idea of this. Sulfur dioxide. Why I gave you this sulfur dioxide? Because when sulfur combines with oxygen, then at this time valency of sulfur is 4, and that's why valency of sulfur is 4 given to oxygen, and valency of oxygen is 2 given to sulfur, because sulfur has 3 different valency, 2, 4, 6. At this time its valency is 4. That's why if 2 atoms of sulfur combines with 4 atoms of oxygen, then certainly 1 atom of sulfur combines with 2 atoms of oxygen. That's why to be bothered with all this, I gave you directly SO2. Look at this caustic potash. Caustic potash means potassium hydroxide. And caustic potash is potassium hydroxide. Caustic soda is sodium hydroxide. And washing soda and baking soda. This baking soda we are using in food substances also while making roti, etc. And washing soda is used to remove the hardness of water. Permanent hardness of water, and it is sodium carbonate. Okay, these are the few compounds which are written in the commercial name, and if it comes in the chemical reaction, you must have idea about them. I mean to say, you must be able to write their molecular formula. You cannot write according to the element what they contain, because you don't know, and that's why I suggest you to remember this, then only you will be comfortable in chemical reaction. Just for example, now I want to give you an example of this. Someone if says caustic soda reacts with sulfuric acid, then caustic soda, we have to remember this. Caustic soda means NaOS. And when it reacts with sulfuric acid also we have to remember directly S2SO4. No need of exchange of valency. We remember them directly, and then you can understand easily. This is metallic hydroxide, base, and this is acid, because acid is told directly acid-base reaction. What is the product? Salt and water. That's why how salt forms, metallic part of the base displaces the hydrogen of the acid, and that's why it becomes NaSO4. Now new compound form, that's why we have to exchange the valency. Sodium 1, sulfate 2, that's why Na2SO4 plus another product of acid base reaction is water. Now you have to balance the equation. There oxygen is 1, but here also oxygen. I don't want to count this because sulfate is present in both the side. I'll count sulfate in left hand side and right hand side. Oxygen 1, oxygen 1, okay. Hydrogen 2 in right hand side. Here 2 and 1, 3. That's why in left hand side it is odd number. That's why I want to make this even, and then I will balance this 2, and here this is odd number. If I take here 2, then 2 plus 2 becomes 4, and if I take 2 here, then hydrogen is balanced. Now what about oxygen? Oxygen 2, okay. Sulfate 1, okay. Sodium 2, okay. This way we can write the chemical equation. There is another problem also. Look at this. Just like this in slaked lime. If you are told slaked lime when reacts with nitric acid, then what happens? Slaked lime we have to remember directly calcium hydroxide, and when it reacts with nitric acid HNO3, we have to remember this also, and these are the commercial name what I told you just now. And whatever, this is metallic hydroxide, this is also base, and this is acid base reaction. That's why salt forms, metal displaces hydrogen. That's why calcium nitrate CaNO3, and calcium valency 2, nitrate valency 1, we don't have to transfer. Calcium, 2 of calcium should be transferred to nitrate, taking bracket, and plus another product is water. Now how to balance it? Now oxygen here 1, here this oxygen I am not counting because nitrate is present on both the side, and that's why I will count nitrate. Oxygen 1, here oxygen 2, that's why if I take here 2, then hydrogen 2 to 4, here 1, and here 2, if I take here 2, then 2 to 4, and then nitrate 3, nitrate 2, calcium 1, calcium 1. This way, if in any chemical reaction some commercial name comes, we have to remember this. There are hundreds, not hundreds of commercial name in your level. It's very few. I mean to say, there are very few in number, 20 or 25 or 30. Some are also, I think, left here. Some are left here. I didn't write all of them because the list may be a little more. But how do we write chemical reaction now? First, we have to remember valency and symbol of the element. Second, we have to remember the valency and formula of radical. And then we have to remember that chloride, nitride, oxide, sulfide means the respective elements are combined. And with the help of these two information, you will be able to write molecular formula. And when we become able to write molecular formula, we can write chemical reaction. But we have to remember the formula of molecular formula of some of the compounds whose name is not given as chemical name, but it may be written as commercial name in the chemical reaction. We have to remember their molecular formula. Okay, this way we can write chemical reaction. In next class, we'll continue with some other. Okay, this much for today.